Welcome to chapter 6. This is where we talked about discrete and continuous random variables. So the difference is discrete random variables have a countable number of outcomes with gaps in between, like how many siblings do you have, number of shirts that you own, number of correct answers that you have on a test. Continuous random variables deal with measurement, temperature, weight, time. Those would be continuous. So for a discrete random variable, the probability distribution is going to look something like this. Could be number of heads that you flip in 3 flips, 0, 1, 2, 3, and then the probability of each. All the probabilities have to be between 0 and 1. They have to sum up to 1. As far as calculating the expected value, you're just multiplying like 0 times 0.1 plus 1 times 0.2 plus 2 times, and just summing those up. That would give you the expected value or the mean. The variance, it's just the distance from the mean squared times the corresponding probability. Summing those up. If I wanted the standard deviation, I would just take the square root of that. Both of these formulas are on your formula sheet. So you don't have to have those memorized by any means. Just to point out where they are, it says discrete random variable. You're looking at there. It says standard deviation instead of variance. That's the difference. For a continuous random variable, that's displayed with a density curve. Typically, the normal curve is what we use. For a continuous random variable, the expected value of the mean is that balancing point. So let's look at some rules for mean and variance. If you have a list of numbers and you have some mean and some variance, and then we add 27, well, now all the numbers went up by 27, so the mean is going to go up by 27. The standard deviation, the variance, remember, is just equal to the standard deviation squared. So if I add 27, I'm just shifting the data. It's not expanding or condensing at all. So every measure of variability doesn't change. The standard deviation doesn't change. So when I square it, it's going to be the same variance. So what if I multiply by 11? Now I multiply all the numbers by 11. The mean's going to change times 11, and the standard deviation is going to, the numbers are going to expand or condense. So the standard deviation is going to be multiplied by 11. But since we're talking about variance, I'm multiplying by 11 squared because it's the standard deviation squared. So rules, basically what I need you to take away from this, means play nice. I remember saying that in class. Standard deviations don't. So whatever it says to do with the mean, just do that. I'm adding the means. If I want the mean of x plus y, take the mean of x plus the mean of y. For variability, for variances, the variances always add. Whether you're adding or subtracting, the variances always add. And if I want the standard deviation, I would just be taking the square root of that. And that's what we did quite a bit in this unit. So finding the mean and the variance, this is a discrete random variable. This is what I showed you above, like the value times the probability plus the value times the probability, so on and so forth. And then the variance, just substituting into that formula. As a shortcut, if it's a short answer question, you'll have to show your work. If not, you could do list 1, list 2, and you could run one variable stats, list 1, and then in the frequency list, put list 2. And that'll spit out your mean and standard deviation. The second part of this unit was on binomial and geometric random variables. So binomial shows up quite a bit on the AP exam, whether it's multiple choice or short answer. To tell if something's a binomial random variable, you're going to check bins. B is binary, you have a success or a failure. I is independent, each trial is independent. N, it has to have a fixed number of successes. And the probability of success has to be the same. So a binomial distribution has 2 parameters, N and P. Formula sheet, it tells you that binomial parameters N and P. So your formula is right here if you want to use that for exactly, or we did some work on the calculator binomial PDF. If you're going to use the calculator, you have to explicitly say what N, P, and X equal. X is the number of successes. Less than or equal to, now it's going to be binomial CDF. So if I want the probability X is less than or equal to 5, that's going to be everything 0, 1, 2, 3, 4, 5. Then I'm going to set X equal to 5. The mean and standard deviation, these are on your formula sheet. That's for binomial. For geometric, this is like the wait time distribution. How long until the first success? And typically this is just showing up in multiple choice. Occasionally it's showing up on the short answer. The BI and the BIS are the same. T is the number of trials until the first success. So there's no fixed number of trials. So this is geometric. You have one parameter, P, and that's it. Oh, let me move that. All right, so there's your formula, mean and standard deviation. These formulas are on your sheet. You could do these in the calculator as well, similar to what I showed on the previous example for binomial, but just with geometric. So let's look at this last example. Mr. Wilcox makes 70% of his free throws. How likely is he to make exactly 7? So this is binomial because we're looking at 10 shots, 7 out of 10. So probability X is 7. So this is 10 choose 7, 0.7 to the 7th, 0.3 to the 3rd. Or I could use binomial PDF. Make sure you explicitly state N, P, and X. And I'm going to get that same probability. Part B, 7 or more. So this is 7, 8, 9, or 10. So this is where you have to do that 1 minus. If you have one of those really newer operating systems, you could put in like a lower bound of 7 and a upper bound of 10, and you'll be fine. If not, you're going to have to do 1 minus binomial CDF. You want to get rid of everything below 7. So that's 0 through 6. So you're going to do X is 6. And that gives you 0.65. Expected number made out of 10. We have a fixed number of trials. This is binomial. So I'm just using the formula N times P. We'd expect 7 successes. That is it for chapter 6. Yeah, hopefully that was informative for you.